Hi, my name's Ted, and today I'm going to talk to you guys about FDM 3D printing. Now, what is FDM 3D printing? It's probably the kind of 3D printing you already know about or have already heard about or seen on TV or in a TED Talk. FDM stands for Fused Deposition Modeling. This is an additive manufacturing process in which layer by layer an object is completed. It's almost like you're drawing with a pencil, an object. Looking down on it from the top, you slice it into many thin layers, the thickness of a piece of paper. You draw out each layer, and you keep drawing and drawing and drawing, and eventually you wind up building a 3D object out of these drawn layers. So, how do we go from a concept in our mind to an actual product? Well, there's a process for everything, and there's definitely a process for this. So, how does it work? Well, first you have to have an idea. If you don't have an idea, you can use someone else's idea. There's all sorts of free online repositories with 3D models. The main thing here in order to start your 3D printing adventure is you need a 3D printable file. Typically this is a .stl file or a stereolithography file. So what is a stereolithography file or an STL file? Is a triangulated mesh structure that's been created from a solid 3D model, right? So what is a solid 3D model? Well, you can make that in a 3D modeling program, or you can get one for free online. If you don't have any good ideas, or you don't have the time to create something of your own, or an expensive 3D modeling software suite, you can always go online and see what's available. There's also many free software suites that are alright, like Google SketchUp is a pretty good software suite that you can use, and it's completely free, and you can make excellent 3D printable files with it. So once you have your 3D printable file, what do? Well, you open up your 3D printer software. In your 3D printer software, you import this STL file, and you will be able to do some modifications to it, but the main thing that this software allows you to do is it converts your 3D model, your STL file, into your various sliced layers and the path the extruder needs to take to complete the object. This language that's used to control this process is called G-code. So the software is fundamentally a G-code interpreter where it takes your STL file and interprets it into G-code. Then on the 3D printer side of it, you have your G-code implementer, and your G-code implementer implements the G-code. It makes the model come to reality. On some 3D printers, the G-code implementation system is standalone, as in the 3D printer is not directly connected to a computer. It works via SD cards where you transfer the files via SD card. Other 3D printers are directly connected to your computer, and the G-code processor or interpreter is also the implementer as well. There are advantages and disadvantages to both systems. Typically, standalone systems tend to be more reliable, but they're less dynamic. So let's go for a quick overview of this process and see how it goes. We're going to begin our 3D printing adventure. The first thing we're going to do in our 3D printing adventure is find a 3D printable file. Well, we can either make one or we can find something off the internet. In this case, I actually want to make a small quadcopter, so I'm going to find what I need off the internet. Alright, so here's the website Thingiverse. Thingiverse is a very interesting website. It allows us to download 3D printable part files. So let's say you want to print a spaceship. So you can find the spaceship in the spaceship section. You find the spaceship you want to print, and then you download it and you print it. So in our case, we're going to be printing this micro quadcopter. So the first thing we do is we download the part file. Once the part file is downloaded, we can open it up in our 3D modeling software. And when we do that, we should have something that looks like this. This is how an STL file looks. In this stage, we can modify or edit the part in any way that we so desire. But the interesting thing to note here is we can really see exactly what an STL file is, how it's a solid model that's been broken into a series of mesh triangulations to complete a 3D form. So once we verify that everything's alright with our 3D model, we can open it up in our 3D printer software. Our 3D printer software looks something like this. In the 3D printer software, we can make small changes to the 3D model to make it more printable or to improve the printing process. So we can move it off to one side depending on what kind of extrusions we're using. We can also change the orientation. Why does this matter? Well, in some orientations, the part may not be very strong or it may not be printable, such as this orientation here. This is not very printable, nor would the completed object be very strong. In this case, we'd want it to lay down flat, quite like this. So once we've made any modifications we'd like to make, we can build our 3D model. So when we go to build our 3D model and create our tool path, we wind up at this stage. We can select various settings for our 3D printer. We can set infill and temperature, various printer configurations, and so on and so forth. So then we build our file. Once the file is built, you wind up with something like this. Now, what's really cool about this software is it actually shows the direct tool path that's going to be taken by the 3D print head, which is a wonderful feature. It can really help identify any issues in the 3D printing process before they become a problem. Once we've completed this, we save our build file to an SD card and we send it to our 3D printer. So when the part's in the 3D printer, it looks something like this as the 3D printer goes along and prints its job. And due to the wonders of movie magic, here is the completed quadcopter frame. Alright, so you may know that 3D printers are a great tool, and they can be used to convert a concept in your mind into an object that exists in reality, such as this small quadcopter frame. But the question is, how does a 3D printer work? How does it achieve this? Well, the 3D printer is fundamentally two simple machines. One is the extrusion system, the other is the Cartesian robot. The Cartesian robot allows the 3D printer to place the extrusion system anywhere within a three-dimensional space. The extrusion system deposits the material that's built up layer by layer to build an object. So let's take a look at this in action. Here we can see a 3D printer building a quadcopter frame. In this particular case, the Cartesian robot is square, while in this one, the robot is triangular shaped. They all achieve the same fundamental goals, but they do it in different ways. There's also a Delta 3D printer, which has become increasingly popular, as you can see in this video. Cartesian robots typically achieve their actuation with the aid of stepper motors and belts, and stepper motors and lead screws. So, this particular machine has a stepper motor that's connected to a belt that spins two lead screws that moves this entire carriage up and down. This X carriage was controlled by a belt that went around the perimeter of the machine here and moved the extruder back and forth like so. The Y-axis moved the whole heated build platform forwards and backwards. On this other printer, we see the X and Y axis remain stationary, and the only axis that drops is the Z axis. The Z axis is controlled by this stepper motor and 4 lead screws. More modern 3D printers have reduced the number of lead screws. The best 3D printers have as few lead screws as possible. Lead screws are prone to an error. that's visible in the parts called Z jitter. This Z jitter is basically the thread pattern, the combined error of the thread patterns of all the threaded rods and lead screws in the machine showing up in the 3D part. The actuation and extrusion process of 3D printing is controlled through electronics and your personal computer. Your computer has software on it that converts your 3D model into G-code, and then the G-code is executed through the electronics of the 3D printer, which consists of a microprocessor and a bunch of motor drivers. Oftentimes these days it's Arduino based. This example is Arduino based, and here you can see the individual motor drives. There's also a graphic interface that allows you to select which files you want to print, and other basic properties of the 3D printer as well. Now, you may have noticed in these motor drivers that there seems to be one extra motor driver. Well, that's because one of these drivers is actually being used to control the hot end. Inside the hot end, we have a resistor, a large resistor that heats up this block, which melts our thermoplastic. The temperature control is modulated using a thermistor or a thermocouple. This is actually the particular thermistor required for this machine. Okay, so at this point you should be familiar with how 3D printers work and the 3D printing process. The question is, should you buy a 3D printer or make a 3D printer, or just pay someone else to do your 3D printing for you? In large part, that depends on the scale of your operations and the complexity of the parts you want to make. So if you want to make parts out of a general thermoplastic such as ABS plastic or PLA, these are really common plastics. ABS is what Lego is made out of. PLA is the most common plastic for 3D printing right now, and they're both pretty good plastics. PLA is an organic plastic, so it's made out of plants. It's biodegradable, but as a consequence, it also has a pretty low melting point. At 40 degrees, 50 degrees Celsius, it becomes quite soft and is pretty much useless for holding structure. ABS plastic, it's a more flexible, but it's also a lot more durable and can withstand higher temperatures. So it's an excellent thermoplastic if you're looking for a more professional material or a more usable product for your 3D printed parts. So should you make a 3D printer, buy a 3D printer, or pay someone else? Well, if you only have to make one or two things and you're making them out of a general thermoplastic, you should probably see if someone else can print it for you. But if you're going to be doing a lot of 3D printing, or you're going to make a lot of different kinds of parts, having your own 3D printer may be pretty handy. So when should you buy, when should you build? Well, you can get some pretty affordable printers off the shelf with warranties like MakerBots, and there's some products by 3D Systems as well that are quite nice. There's all sorts of stuff out there online now, and some stuff is being commercialized and will soon be available in stores. These printers are quite affordable, and they are backed by a warranty, but if you want to do any modifications or add-ons, you may run into problems. It's kind of a closed operation, and it's difficult to modify some of these printers. So if you want a larger material diversity in your 3D printing operations, or if you want to print something special or in a different way, if you're a tinkerer, if you want to play around, you should probably be building your own 3D printer. If you want a 3D printer that's really large and prints in concrete, again, you know, there's not a lot of off-the-shelf options there. You're probably going to wind up building your own 3D printer. So how does the 3D printer extrusion system work on the most common kinds of 3D printers? Basically, you can extrude anything about the consistency of peanut butter without many issues. This viscosity seems to work out quite nicely for the currently existing 3D printing algorithms that are available on off-the-shelf machines and in the open source community. If you want to print in some sort of a liquid or a two-part epoxy, You're going to be doing a lot of your own software writing. That could be quite a project within itself. So these are all the kinds of factors you want to consider when you're going to make your investment. Operating a 3D printer is quite affordable. They typically don't cost too much to operate. The main expense you're going to have is the 3D printer filament. This is ABS filament right here. It's 3 millimeter in diameter, and it's actually quite flexible, as you can see. If this was PLA, it would break. PLA is a little bit more brittle, and the plastic typically comes in either coils or it comes in spools. The coils look like this. When selecting 3D printable materials, the main issue you'll run across in the additive manufacturing process of FDM 3D printing is shrinkage. So what is shrinkage? Shrinkage is basically a byproduct of the cooling process. So as the filament is being laid, it is cooled, and as it's cooled, it shrinks. Some plastics shrink more than others. If they shrink a lot, you wind up getting very warped components such as this. This was the quadcopter frame that I tried to print in ABS, and as you can see, it's not quite right comparatively. So different plastics have different properties, but the main thing you're always going to run across is shrinkage. Other problems you may run into in thermoplastic 3D printing oftentimes will relate to temperature and extrusion control. A lot of the time your extruder will get jammed or not be working properly, or you'll have inconsistent temperature control leading to a variation in part quality. This is still something that hasn't been fully overcome in FDM 3D printing using thermoplastics. Thermoplastic 3D printing is an excellent solution for a lot of people, but maybe it's not a solution for you. Maybe you can't control the viscosity of the material you're working with using temperature. So what can you do? Well, you can always control the viscosity of the fluid around what you're trying to print. So for example, you can print in a liquid. Another application requiring a specialized 3D printer may involve multiple extruders. Why would you want multiple extruders? Well, maybe you're printing some sort of electrical system, in which case you need different components to be made out of different materials. Some of those materials may need to be conductive, and other materials you may want to be an insulator or a strong insulator even. And in this case you may want multiple extruders. Yet another application for a specialized 3D printing system would be the printing of truly curved or round objects. Current 3D printer technology and Cartesian robot technology typically isn't based on rotating objects. If you desire to print truly rounded objects with a lathed quality to them, having a rotating print base may come in very handy. Before going out on your 3D printing adventure, there may be a few things you want to consider. For example, you may want to consider what makes a strong part up, how to lay out a part to have it print in a stronger way. You may also want to consider how the force is going to be distributed in the part if the part's going to be used for any kind of physical strain. Another thing you may want to consider is how the extrusion system is going to be controlled. Are you going to use a conventional extrusion system with conventional extruders, or are you going to be making your own thing? Are you going to be using maybe liquids? Then you can even have a gravity-fed extrusion system, and how are the electronics going to control these systems? Furthermore, another thing that should always be on your mind is shrinkage. Shrinkage is always going to be a big problem with 3D printing. As parts cool or cure, they change shape, and this is typically called shrinkage in the 3D printing world. Another thing you may want to consider as well is what materials you can use with current technology to achieve your goals. Maybe there's something out there that's a thermoplastic that's not currently commonly used in 3D printing. Maybe you can just buy a 3D printer or build a simple 3D printer and find a material that works well as a thermoplastic. Or maybe you can even adapt a current 3D printer, make some modifications to the extruder or hot end assembly, and print something else altogether. So those are just some things you're going to want to think about and try and answer those questions before you go out on your 3D printing adventure. Till next time, have fun and goodbye.